The first of the formula that we are going to be looking at is the sine rule, the sin rule. Doesn't really matter how you say it. Sometimes it helps saying sin, because then you can distinguish between this being negative. So it's the sine, and this is sin. Doesn't matter though, whatever. Okay, so sin rule says, and you can use either or of these. You will only be given one of them on your formula sheet once you graduate to be allowed to have a formula sheet, which is at the end of grade 11 for the first time, like in the exams, unless the department says no. So what sine rule says is the sin of angle A over side A is equal to the sin of angle B over side B is equal to the sin of angle C over side C. And it also says the opposite. Okay, so the ratio between the sin of whatever angle and the side opposite that angle, they will always be equal to one another. So how do you use this when you use this? If your question is asking for an angle, so I'm going to just put an angle symbol there. What you need is two things. The one is the opposite side, and the other thing is an angle and its opposite side. So the pair. So for example, if you are looking for angle C, you need to have the side C's length, and then you need to have a pair. So you either need to have the angle there and the side, or the angle there and the side. So you need 3 bits of information, okay, so that you can substitute it in there. This is if you're looking for an angle. If you're looking for a side, then yes, you also need the angle and a pair of angle and its opposite side. But instead of needing the opposite side, if you were looking for a side, you need its opposite angle. Yeah, and that's all you need. So yes, there is a proof for it. We're not going to be looking at the proof in this video. That video will happen at a later point when I have the energy for that. But you need to be able to prove this rule. And yes, it's examinable. Even in matric, it's examinable. We're going to go look at examples now, though. Here's our first question or first example. We are given a triangle. The triangle is named ABC. So if you want, you can start by adding, if this is angle A, then the side opposite it is small a. If this is angle B, the side opposite is small b. And this is C, then this would be side C. And they gave us 50 degrees, 60 degrees, and then this length over here is 10 units. And the first thing that they are asking us is to find the length of AC. So firstly, for AC, you need to notice AC is small b, which is opposite angle B. And then you were given a pair of an angle and a side. We already know that both of those. So to find a side, we need its opposite angle, which we have, and we have a pair of an angle and its opposite side. Okay, so we have everything we want. We are looking for a side, however. So it doesn't matter which one of the two you want to use. But I would advise, if you're looking for a side, the sides are on top here in the numerator. So if you're looking for a side, use this second formula. If you're looking for an angle, use the first one because the angles here are on top. It just helps with calculations because we often make unnecessary mistakes when we're working with fraction. So we're going to use this version where small letter b, which is AC, over sin b is equal to small a over sin a. And you do not have to write down the formula first. You can, however. So we are looking for AC. So it's easier always what you're looking for to put that first. Then what we were given is opposite small b, which is AC. We have 60, so this would be sin 60. And then we were given a pair, which is the sides are on top. So A is 10 over sin 50. And then all you need to do is to find AC on its own. So we are dividing here by sin 60. So to get a divide by sin 60 to the other side, we have to multiply with sin 60. So we can find AC by having whatever we had there already, and we just times the sin 60. So we just pop that into our calculator now, and then we'll get an answer. And we have gotten all the way to the end of the question, so you can just say 11,31 units. Okay. If you decided to first find this answer, I do not advise rounding in the middle of a calculation, which is why I didn't find this answer and then multiply. The world will not end if you do. If you do make that decision for yourself, I would keep more than 2 units. I'd keep like 4 or 5, or just store the value in my calculator. Because it's just good form in maths, not to approximate, not to round until the end where we actually ask you to round, because your question paper will say round to 2 decimals or whatever. We now have B is 11,31, and then we are looking for AB. So AB is C. So we are now looking for this question. There's our pair that we have already, but you can also use this. Obviously, you might get a slightly different answer because that's an approximation. And we need to find AB, which is opposite angle C. We do not have the value, but we have 50 and we have 60, and we know this is a triangle. So C will be 180 minus the 2 angles that we have, because we know the angles in a triangle add up to 180. So this is 70 degrees, and our reason would be interior angles of a triangle. It's just good form to put your reasons there, even if they don't want, or they don't specifically ask for it. You never know how that memo is set up. So rather have it there. Okay, so now we are looking for a side again, and that side that we are looking for is called AB over, and the other side is 10. AB is opposite sin 70, and 10 is opposite 50, so sin 50. And then we just have to multiply with this thingy that we're dividing by. So to find AB, we're going to take what we already had on the right-hand side, and we are going to multiply with what we are dividing here to get it to the other side. Put it in our calculators, and then we are going to get 12,27 units. Then in triangle DEF, we are given the angle here is 100, and this is 20. Do you already see they are opposite one another? So that's your pair, your solid pair where you have the numerator and the denominator. Then we are given that this over here is 7, which would be opposite angle F, but they are asking for D. So in other words, our pair usually would be, we have to find EF, okay? But we don't have that. Okay, so we don't have a pair here. We have neither the information for D or for EF. So we need to find F, and then we can use interior angles of a triangle. In this case, however, we are looking for an angle. So instead of having your sides on top, have your sin with the angle on top. So we are going to be looking for angle F, right? So sin F over side F is equal to, the pair we have is with E, so sin E over side E. And we're looking for sin F. The pair that we were given is sin 100 and size length 20. And then the other angle, the F that we're looking for, has 7 opposite it. So we first need to find sin F by, we're dividing here by 7, so we multiply by 7 to get it to the other side. And then we want angle F size, not sin F. So to find an angle, given the trig ratio, we use arc sine, which is on your calculator, shift and then the sin button, the one that has the -1. So again, I would not round in the middle of my calculation. It's just good form. So everything there, you're going to use shift sin, just shift sin. Just remember to put your brackets and close it again. And then you put all of this in your calculator, and you are going to get 20,16 degrees. Technically, if you want to get technical about this, because remember we have done stuff like this before, we call the general solution. We would go and work and see, okay, this is our cast diagram. Sin is positive everywhere between 0 and 180, which is what you can have in a triangle because it adds up to 180. So technically, there's another angle, which would be 180 minus that, because this is theta and this is 180 minus theta. But you will only use this portion if they tell you it's an obtuse angle, triangle, or if the angle you're looking for is obtuse, which in this case, it can't be because we already have an obtuse angle. We can't have two obtuse angles in a triangle. So this is what we have, but this is not the question. We want D. So we're going to say 180. And again here, maybe keeping like 4 decimals would have been better. It's not the end of the world though. And you say 180 minus the 100 and minus the 20,16. And then we're going to get 59,84. And our reason would be interior angles of a triangle, or you can say angle sum in triangle or sum of angles in triangle. Just go double check your reasons on your official list. And we're going to look at one last example, and this is now where they told us about an obtuse. So now you need to keep in mind again, as I said in the previous example, sin is positive in both of these quadrants. So everywhere between 180, between 0 and 180, where this is just theta and this is 180 minus theta. So if we're working with an obtuse angle, we're going to be working in this quadrant. Then they give us this length here is 15, and opposite the road from it is 30, so that's our pair that we will automatically have. We are given this 25, which is opposite k. So if you want to go label, which is not necessary, this is k, so this is small letter k. Angle M, so small letter m, angle L, and small letter L. And we are looking for angle K. We already have the 25 and we have the pair, so we have everything we need. We're looking for an angle though, so we're going to put our angles on top. So sin K is what we're looking for, and our other angle is 30, which is opposite the side that is 15, and K is opposite the side that is 25. Then we are dividing by 25, so to get it to the other side, we multiply by 25. And then to just get angle K, we are going to say shift sin, or more specifically, it's called arc sine or arc sin. And we're going to put that whole thingy in there inside the brackets. And then we're going to get an answer of 56,44, which is not an obtuse angle. So this is not applicable. This is not the answer. So actually K would be 180 minus 56,44. So it's not this one because it's not acute. You subtract it because that's our theta basically, our reference angle. And then our actual answer will be 123,56, which is an obtuse angle. In the next video, we're going to be looking at cosine rule or cos rule, and then in a later one, error rule, before we get all of the stuff together after that.